Hey there, in this video we're gonna start covering section 2.1, functions. So what is a function? A function is a relation or a rule that assigns to each element x in the domain exactly one value y in the range. And so you may have seen function machines before. And so when you have a function, say for example I have something like 2, it gets put through the function machine, and so this is your input 2, and the output that comes out is 7. So this equates to the point 27. And then if I have 3, goes to 8, so then this becomes 3, 8. So the x's are your inputs and the y's are your outputs. And if I have 5, goes in, and then 8 comes out, that's the point 58. So is this a function? So a function says it's a rule that assigns to each element x in the domain, the inputs, exactly one value y in the range. So notice the inputs or the domain are 2, 3, and 5. So the domain are 2, 3, and 5. And when we look at the outputs, does each input have exactly one output? Yes, 2 only goes to 7. So it only has one output. 3 only has one output, it goes to 8. And 5 also has one output, it goes to 8. Now 8 is a common output, but each input goes to just one output. So this will be considered a function. So domain will be 2, 3, 5, and the range, the outputs, will be just 7 and 8. So these are the inputs, which is a domain, and these are the outputs, the range, which are the y values. Now something that may not be a function would be, say I have another example, and this time I have, say 2 goes to 7, just as before. So this input has only one output, and then we're going to have 3 goes to 8, and then 3 goes to 9. Now notice that this is not a function because the inputs don't have exactly one output. 3, the input 3 has more than one output, has 8 and has 9. So this is not a function because 3 has more than one output. So that makes it not a function. So a function is a rule that assigns to each input exactly one output, each element in the domain exactly one element in the range. And so when we have a function, usually you'll see a little function machine. So if you have x and then it goes into a function machine of sorts, we'll call it f of x, then the output that comes out is your y. So y equals f of x is the output. So let's explore some functions. So say I have, I'm going to go back to my oval. Say I have 2 goes in and 5 comes out. So this becomes, so x goes in, y comes out. So this is the point 25. And then let's say 7 goes in and 15 goes out. So this is the point 7, 15. So let's try to guess, what is this function machine doing? So let's try another one. Say 5 goes in. Can you guess what's going to come out based on the first two outputs? So 2 went in, 5 came out. 7 went in, 15 came out. Now 5 goes in, and if you guessed it, yes, 11 comes out. And so this is the point 5 comma 11, right? This is again your x and your y coordinate. Let's try a negative number. So negative 3 goes in. So now what comes out? And if you're seeing the pattern, you might already know that negative 5 comes out. So what is the rule? So if x goes in and into this function machine, what comes out. So what are we doing to the x values, to the inputs? So notice that to get a 5, so close to 4. So 2 times 2 is 4, and then you're adding 1. What about 15? Because I could also say 2 squared is 4, and then I'm adding 1. But then if I square 7, 7 squared is 49. That doesn't get me close to 15. But if I multiply it by 2, 2 times 7 is 14. Add 1 is 15. So let's check it with 5. 2 times 5, that's 10. Add 1, I get 11. 2 times negative 3 is negative 6. Add 1, I get negative 5. So it looks like what this function machine is doing is multiplying by 2 and then adding 1. So when x goes in, what comes out is 2x plus 1. So as a coordinate point, right, this will be x and 2x plus 1. Or you can say y equals 2x plus 1. But when we want to write the function notation, this says that f of x equals 2x plus 1. And so these are essentially points on a line, the line with y-intercept 0, 1 of slope 2. So that's what this function was doing. Let's try another example. And at any point you can pause if you want to take notes. So let's try another function machine. Say we're going to have 2 goes in, and this time 2 is going to come out. And we'll call this one G. So what could be happening here? So with one value, we can't really tell. So we'll go to 5. 5 goes in, so now 23 comes out. So you might guess what the rule might be. So let's try a negative number. Negative 2 goes in, what comes out? 2 comes out. And let's say 3 goes in. Can you guess what comes out based on these other inputs we've done? If you guessed it, yes, 7 comes out. If you guess 7, then you know what the rule is. So that means if x goes in, what is happening to x as it enters this function machine? So it looks like we are squaring it. Right? 2 squared is 4, then subtracting 2. 5 squared is 25. When we're subtracting 2, we get 23. Negative 2 squared becomes positive 4. Subtract 2, you get 2 again. And 3 squared is 9. When you subtract 2, you get 7. So we're squaring the input, and we're subtracting 2. So this becomes x goes to x squared minus 2. And so the way we write that is, we're going to say f of x equals x squared minus 2. As a coordinate pair, this will be x comma y, but y is the x squared minus 2, right? F of x is just a fancy name for y. And so when you have it like this, when we're talking about the domain of the function, then we can be a little more explicit. Once I have the rule, I have to take into account any x that could be an input for that. And so this is where knowing the graph of the function might be helpful. So let me go back to the previous one. Let's try the domain for the first rule that we had. For f of x equals, we had 2x plus 1. Oh, and I just realized we had called this function up here g. So let's call it g of x is x squared minus 2. Right, so I said let's call this one g up here. So then we express it as g of x equals x squared minus 2. So the domain for the first one we did, for f of x equals 2x plus 1, the domain is all the x values for which there is an output. And essentially, if no value of x will make this undefined, then the domain is going to be all real numbers. So can you think of any x that you cannot put here? And I can't think of any, and especially if you look at the graph of this function, that this is a line with slope, we said 1 and slope of, or y-intercept 1, sorry, and slope of 2. So this is our line. And notice that the arrows maybe keeps going forever, so there are no missing values here. So the domain is all real numbers. So how do we say all real numbers? We say minus infinity to infinity. The range is also going to be all real numbers, right? The range is the y values for which the function is defined. So the range is also all real numbers. So let me write that down. So the domain is all the x values for which a function is defined. And the range is similar, but all the y values. For which a function is defined. So for example, if I give you a function f of x is equal to, say, 1 over x, notice here, right, is there an x you can think of that is not defined, that is not going to have a y value? And as soon as I see that I have a fraction, I know we cannot divide by 0. So I can already tell from here, I don't want x to be 0. So, but everything else will be fine. So x can't be 0, so my domain, and I can write it different ways. I can say the domain, I can write it in words, all real numbers, except x equals 0. I can write it in interval notation. I can say minus infinity to 0, but I don't want to include 0. And then everything else above 0, so or union 0 to infinity. Or I can write it in set builder notation. And set builder notation will be all x's such that x is a real number. So this is kind of, you write it partially in words and partially in symbols. X is a real number and x is not equal to 0. So those are the different ways that we can write the domain. In the next video, I'm going to talk about evaluating functions, and we're going to work a little bit more with domain and range.